Measurement of power and power factor using wattmeter method. Aim of this experiment is to measure the power and power factor using wattmeter method. Okay, apparatus required are a single phase auto transformer is required of 230 by 0 to 270 volts. We need one auto transformer, quantity is 1. Voltmeter is required whose range is 0 to 300 volts, type is MI and quantity required is 1. We need an ammeter whose range is 0 to 5 amperes, type is MI, moving iron type, quantity required is 1. We need a wattmeter uh, of 300 volts, 5 amperes, unity power factor type, we need 1, quantity 1, and connecting wires as per the requirement. Okay, let us see the circuit diagram to do this experiment. So here we are going to determine the power and power factor of this rheostat. This is our resistive load. Okay, so this is the rheostat which has 3 terminals. This is one terminal, fixed terminal. This is one terminal, fixed terminal. This arrow mark represents the variable terminal. Okay, so here supply, this is our supply of single phase 230 volts AC supply. This is the phasor neutral of this supply, and this is our double pole single throw switch, and these are the fuses of 5 amperes. So this phase is connected to the input terminal of the phase terminal of the dimmerstat. So let us assume this is our phase terminal, input phase terminal of dimmerstat, that is single phase auto transformer. You can even call single phase auto transformer as dimmerstat. So this is our input phase terminal of auto transformer. This is our input neutral terminal of auto transformer. So the phase of supply is given to the phase input terminal of your auto transformer. Neutral of supply is given to the neutral input terminal of auto transformer. Let us assume this is our phase output terminal of auto transformer. This is our neutral output terminal of auto transformer. Okay, so across the phase and neutral output terminals of your auto transformer, a voltmeter is connected. So whatever is within this dotted line, that is our single phase auto transformer. Okay, so across this phase and neutral output terminals of your auto transformer, voltmeter is connected, whose range is around 0 to 300 volts, moving iron type voltmeter. And from the phase, we must give connection to the common terminal of ammeter. Okay, ammeter range is 0 to 5 amperes, moving iron type ammeter. And from terminal 5, since the range is 0 to 5, from terminal 5 we must give connection to M terminal of the wattmeter. So this is our wattmeter. Okay, so wattmeter will have 4 terminals: main M, common C, line L, voltage V. Okay, so or voltage or volts we can say. So 5 should be connected to M, and M and C are short circuited, and L, that is line of your wattmeter, must be given connected to the variable terminal of your rheostat. You can even connect to fixed terminal, it doesn't matter. Okay, but here according to this diagram, so L is connected to the variable terminal of your rheostat, and V should be connected to the neutral output terminal of your dimmerstat, that is single phase auto transformer, and one of the fixed terminals, this is fixed terminal and this is fixed terminal. Any among these two fixed terminals, one fixed terminal should be connected to the neutral output terminal of your single phase auto transformer. Okay, so this is our circuit. So let us see how to give connections practically. So this is our supply unit. This is our supply unit. So whatever input supply that we will give, that voltage, input voltage, will be displayed on this display unit. So this is a double pole single throw switch. Okay, so green is the on button, this is the off button, red is the off button. So now this is our dimmerstat. So it will have, these are phase and neutral input terminals, phase and neutral output terminals. Okay, input and output terminals. Now the range of auto transformer was 230 by 0 to 270 volts. So input was 230, output is 0 to 270. You can see 0 from here. If you move like this, see it is 270. So you can vary the voltage up to 270, output voltage up to 270. Okay, this is our demostat, that is single phase auto transformer. Okay, so we need a voltmeter, MI type voltmeter. Okay, so for MI type voltmeter you can see a sinusoidal symbol here. This is our voltmeter whose range is 0 to 150. Okay, so scale is for 0 to 150, but we require our range was 0 to 300. Okay, scale is here for 150. So but you can see here above 150 300 and above 300 600 is required, is written, sorry, 600 is written. So even if the scale is of 150, you can get the readings for 300 also. How we will get, I will tell you later. So this is ammeter whose scale is from 0 to 5 amperes. So our range was also 0 to 5 amperes, so not at all an issue. Now this is our wattmeter. Okay, wattmeter whose scale is from 0 to, here it is written 375, isn't it, 375, and if required 750, and if required 1500 also you will get. Okay, so I am just lifting these meters. So now if you see, this is common terminal, common of your voltmeter, and our range was 300, so this is 300 terminal. For ammeter, okay, for ammeter this is common and our range was 5, so this is 5, terminal 5. Okay, next for wattmeter, M, C, L and V. Here you can see different values, 75 volts, 150 volts, 300 volts. So our in our the specifications of wattmeter was 300 volts, 5 amperes, UPF type. So 300 volts terminal is this of your wattmeter. So this is our rheostat. This is our rheostat. The upper terminal is the variable terminal. Okay, so this rheostat will have two fixed terminals. This is one fixed terminal, this is another fixed terminal. Okay, so two fixed terminals, this one and this one, these are the fixed terminals, this one is the variable terminal. So now let us give the connections. So I am going to take a red wire to give connection from phase. So this is my phase terminal of supply phase, supply neutral. Okay, so from supply phase I am going to give connection to the phase input terminal. This is it, from supply phase to input terminal of the demostat, phase terminal of the demostat, input phase terminal of the demostat. Similarly, I am going to take another wire, I am going to give to the neutral, supply neutral, to the input neutral terminal of your demostat, that is auto transformer. So this is it, these are the input connections. Okay, this is my phase, red one, black one is my neutral. Okay, so input connections we have given. Now let us give the output connections. So I am going to take one more red wire. Okay, you can take red or black, it doesn't matter actually, but I want to give phase connection to the red wire. So from the phase, give connection to the common of your voltmeter. Okay, from the phase, output phase of your auto transformer, give connection to the common of your voltmeter. Okay, now from the neutral, okay, from the neutral, that is output neutral terminal of your demostat. So my range was 300, voltmeter range was 300, so I am going to give connection to 300. So from the output terminal to output terminal phase, okay, phase to common. Next, from the output terminal neutral, here someone has written PH and N. So okay, from the output terminal neutral to 300. Okay, so voltmeter connections are over. You can lay down the meters and make sure the wires are not on the this display. Okay, so we have to take the readings. They should not be on the display. Now I have taken one more red wire. So it's not necessary to take red wire, but so from phase I am going to give connection to common of the ammeter. This is my ammeter. To the common I have given connection. So from the phase output terminal of your single phase auto transformer, I have given connection to the common of your ammeter. Now my range of the ammeter was 0 to 5. So from 5, okay, of the ammeter, from 5 of the ammeter, I am going to give connection to what? M. Okay, so from 5, so we must give connection from 5 of ammeter to the M terminal of the wattmeter. Now here M and C should be short circuited. So I am going to insert this small wire here. It's not going inside. Yeah, so I have inserted it. Now this is it. I have short circuited M and C. Next, okay, so this L, here L is there. L should be connected to the variable terminal of your rheostat. The upper terminal is the variable terminal. Okay, so upper terminal is the variable terminal. Next, this 300 should be connected to what? This is 300. Okay, this is 300 V. This is our V. M, L, C. This is V. 300 wherever it is written, it is 3. From here you must give connection to the neutral. This is our neutral. Okay, so to the neutral. So this connection is from 300. You can see 300 there. Okay, from 300 you must give connection to the neutral, and one more connection we have to give. So to the neutral I must give black wire connection. I don't have black wire. So here actually I have a red wire. So I am giving red wire here. Why? Because I don't have black wire here. So I have taken a red wire and I have given connection to the fixed terminal of your rheostat. From there I am giving connection to the neutral. Okay. Okay, we can give either red or black, but if we give black to the neutral, it will be more specific. Okay, so it will be more specific. Specifically, we can understand it is a neutral connection. If we give black, that it doesn't matter. Okay, so from the fixed terminal, I have given connection to the neutral. This is it. So these are the wattmeter, voltmeter, ammeter, and thermostat and rheostat connections. Okay, so you can check how current is flowing through the rheostat, because rheostat should be at maximum output position. Let us check it. So you can see from L current enters. So from L, okay, so from L terminal of this wattmeter, current enters through this knob and it will flow through this hollow tube. Wherever this knob is there, from there current will get down and I had a pen with my hand. I left it somewhere. Okay, so current will get down from here. Current will flow throughout this coil and it will return back through this wire to the neutral terminal. So this is our neutral terminal, isn't it? So that's why this rheostat, since the current is flowing throughout this rheostat, it is in maximum output position. So if you want, you can, I am moving this knob towards this side. Now from L, current will enter this knob. From this knob it will get down and it will return back. Okay, so in this case current is not flowing throughout this rheostat, therefore it is in minimum position. So rheostat should be at maximum position. So I am moving this to the other side. Now from L, terminal L, see, from L, this red wire, current will enter through this knob. It will flow through this hollow tube. From this knob it will get down. It will flow throughout this wire wound coil and it will return back through this wire. Okay, towards the neutral point of your auto transformer. So since the current is able to flow throughout this rheostat, this is said to be in maximum position. Now let us lay down the meters. Okay, and move the wires away from the display. Okay, this is it. This is voltmeter, this is ammeter, this is wattmeter. Okay, so these are all the connections. Okay, voltmeter pointer, you can see it is at the 0 position. Ammeter connection, ammeter pointer is also at 0. Wattmeter is also at 0 position. Okay, all the meters pointers are at 0 position. Okay, 1 second, my laptop has gone to the now I am going to open this tabular column. This is my tabular column. I am going to note down the readings here. So I am going to write down the serial number here. Okay, I will take 4 to 5 readings, but I have taken enough columns here. So let us note down the voltage, current and power from the experiment while doing the experiment. So voltage, I have assumed notation is V, current I, power P. Okay, so to measure the power factor, P by V into I. So you have to determine the power factor using your calculator. You have to calculate the power factor. Okay, so let us do the experiment. So before starting the experiment, make sure there is no loose connection. Okay, you should avoid loose connections and make sure thermostat at 0 output position. And I'm just pressing these knobs, making sure there are no loose connections. Okay, loose connections should be avoided. So now let us turn on the power supply. So what we have to do is just DPST switch. It was earlier in off position, now you can see on. Now you can see light is glowing here, but pointer is still at 0 position. So press the green button. As soon as you press, you can see voltage is approximately 200, 210, 220, 230. So it is approximately 230. Experiment. Now I have turned on the supply. It is around 230 volts. Now I have to apply some voltage. So by varying the thermostat. So what I am going to do is I am going to vary the thermostat. Until I want to apply around 60 volts. So 60 volts. But here I have given connection to 300 volts. The scale of this meter is scale is from 0 to 150. But I have given connection to 300. Isn't it? I have given connection to 300 here. Therefore, Whatever reading that I got, relation between 150 and 300 is 150 into 2, I will get 300. So, okay, since scale is for 150, so whatever reading that I get, I must multiply it with 2. Okay, whatever reading that I get, I must multiply it with 2. Similarly, ammeter, I have given connection to 5. Okay, see, 5 terminal. So 5. So but scale is from 0 to 5. So whatever reading that I will get, I must take it down as it is. Wattmeter. So wattmeter, if you see, so here our if you see at the bottom of your wattmeter, if you see here, it is mentioned for 5 amperes, join B1 E2, E1 B2. So that you must check before connections, before even turning on the supply. It is already connected for me, that's why I didn't check it, because I already knew that B1 is connected to E2 and E1 is connected to B2. That you can see here. So here B1 and E2 are connected, and B2 and E1 are connected. Okay, B1 E2 and B2 E1, they are already connected. That's why there was no need for me to check, but you must check it before turning on the supply. Now here you can see multiplying factor. So our range was 300 volts 5 amperes UPF type wattmeter. So voltage was 300. Okay, so you can see 300 volts and current was 5 amperes. Okay, so now if you move from 5 amperes up to here, and if you move from 300 volts up to here, you can see there is what is written, they are intersecting at this point, that is it is written 4 here. Okay, so for 300 volts 5 amperes, what is our multiplying factor? It is 4. Okay, multiplying factor is 4. So whatever reading that you get in the wattmeter, you must multiply it with 4. Okay, now so pointer of voltmeter is at 0 position. What I am going to do is, I am going to vary this thermostat, that is auto transformer, until I want to apply 60 volts. So if I want to apply 60 volts, pointer should be at 30. Why? Because because the scale is for only 150, and whatever reading that I will get here, I must multiply it with 2. So if the pointer is at 30, that means 30 into 2 is 60 volts. So I am going to vary the thermostat now. So you can see I am moving the thermostat. Pointer is also moving. Pointer is moving, isn't it? I am moving the thermostat. Now pointer is at 30. So I have already varied this thermostat. See, it is not at 0 position now. So it is showing approximately nearby to 60, isn't it? So here we have given connection to 300. Okay, 300. Therefore, so 30 into 2, I must write it down. That is 60 volts. So for 60 volts, what is current? Current is approximately 1. Okay, maybe approximately 0.9. I am considering it as 1. Okay, so 1 ampere. And what about this wattmeter reading? It is nearby to 0, isn't it? It's not even not nearby to 0. It is in between 25 and 0. So in between 25 and 0 means I will consider it as approximately some 15 watts, 15 into 4. Okay, so I will write it down here in my tabular column. So my voltage was 60 volts. 30 into 2 is 60 volts. Current was 1 ampere. Power was approximately it was in between 25 and 0. So I will add some value in between, some approximate value 15. I am assuming it as 15. 15 into 4. Okay, so if I multiply 15 with 4, 15 4s, I will get 60. Okay, it is around 60. 15 into 4. So it is around 60 volts. So I have got this. What did I do? 15 into 4. This is what I have done. So if I multiply 15 into 4, I'm sorry. Okay, 15 into 4 I will get 60. So for voltmeter what did I do? 30 into 2. This we should not write in the table. Since I am giving explanation here, since I am explaining it to you, I have written here, but you should not write in the tabular column like this. Okay, you should not do that. Okay, now let us go to the next reading. So now I want to apply around uh, 80 volts, means the pointer should be at 40. So I am going to vary the dimmer stat until the pointer reaches 40. Okay, so 40, and here it is, you can see nearby to 80 dimmer stat, and here it is 40. 40 means 80 volts, and it is approximately 1.1 to 1.3 amperes, 1.3, and it is 25 into 4. Wattmeter reading is 25. Okay, so wattmeter reading is, so I must look like this. It is approximately 25. This is current is 1.3 amperes. The voltmeter reading was 40 into 2. So 40 into 2, you will get 80. Okay, current is 1.3, and this was approximately 25 into 4. It is almost 100. Okay, it is 100. So this is it. So these are my 2 readings till now. Okay, 1 second.